this was 2005. This was in '05.
Okay, welcome, good morning everyone, and thank you all out there and here for joining us today at the Washington Alexandria Architecture Center for On the Record with Virginia Tech. And we're here to preview the FutureHAUS Dubai. We're going to look at the next smart, sustainable modular home that will be heading to the world stage this fall in November to compete in the U.S. Department of Energy's International Solar Decathlon Middle East in Dubai. My name is Susan Piedmont-Palladino, and I'm an architect, professor, and director here at what we call the WAC, Washington Alexandria Architecture Center, which is Virginia Tech's unique center for graduate and upper-level undergraduate studies in architecture, landscape architecture, and urban design. And it's also Virginia Tech's foyer to the National Capital Region for all things design and construction and planning. So we're happy to host the FutureHAUS team this morning. So at Virginia Tech, the future is already here. We have faculty and students on campus designing the house of the future, one which will be completely powered by solar energy, loaded with smart technology, responsive to voice commands, and built in a factory to fit anyone's budget and lifestyle needs. From homes to condos, hospitals, hotels, and disaster relief shelters, smart building design is attracting interest from global architecture practices, consumer brands, and foreign and domestic governments at all levels. So here to tell you more about this innovative Cartridge concept housing and how it's a practical and affordable solution to meeting the growing world population housing needs and addressing the climate change crisis, I'm proud to introduce Joe Wheeler. I'll say a little bit about Joe before he steps up here. Joe is a professor of architecture at Virginia Tech and co-director of the university's Center for Design Research, a globally recognized innovator in the areas of housing industrialization, environmental sustainability, and technology integration. As the leader of Virginia Tech's FutureHAUS project, Joe has spent over a decade helping student researchers and industry, government, and academic partners explore solutions to the world's global housing challenges. His areas of expertise include home building to industrialize processes, modular construction, energy efficiency, and smart home technology. And here at the WAC, we are proud to call Joe an alum, as he spent time here as a student and teaching. And so we're glad to welcome him back here to talk about this project. Joe.
I need to hire Susan as my spokesperson. I don't think I need to say anything more. I have been putting together a few sentences for a Hanley Wood publication. They asked for me to say a few things about our work in relation to upcoming crisis is going to happen, a shortage of building trades. When the next housing boom does happen, a lot of the home builders are very nervous about not having the trades needed to meet the demands for this house, especially with the growing world population that we're going to see, I think by 2050, 3 billion additional, and mostly in urban areas. So in thinking about it, just took an hour yesterday and thought about what is the benefit of building something off-site versus on-site? What are the benefits? And I have this list, and it's actually pretty convincing that we should be moving in this direction of prefabrication. Better integration of smart home technologies. As we start to, we're in the digital age now, and we have, all of this technology. We have the voice control. We have a lot of digital technology we don't know what to do with, and we really have to think about how to integrate it into our homes. So prefabrication allows the kind of a process that this quality control, factory-built things. So you're building a house like in a factory, like you'd build an appliance or you build a car, right? So can we move home production to kind of that kind of area? So it provides a better environment for installing these complex components, improving the quality control. Producing something inside, indoor factory production, allows for climate control and allows for multiple shifts, so you can ramp up production. You know, you're in the day, you're in artificial light, you can run a factory 24 hours a day. A more sustainable building process, less waste in a factory, more quality control, mass production, the economy of scale, right, that you get. Lean construction processes. We're consolidating the trades. So we're not sending our plumbers and our electricians out to every individual job site. They're coming to the factory. Does the factory become a trade school where there's interns, where there's, they teach new, younger generations skills. We're losing these trades. The employment of CNC processes. Digital fabrication, that you can't bring a robotic arm out onto a job site, right, to every individual house. But you can set up a facility with all these CNC processes and make production, much more efficient and precise, right? Simple on-site assembly. Once the components are built, there's less complicated assembly that happens on the site. So right now, smart homes, you're sending your IT people out to install all these complex systems, out in the field. And it's just not the right environment to be doing something sophisticated like this. Faster construction time, ultimately, saving money. And what about cost certainty? You know exactly how much the house is when you order it. That's what you pay for it. Change orders are gone, right? So I put that together, and that's just a side note kind of what we're doing here. FutureHAUS, what it really is, it's a result of 10 years of research at Virginia Tech on how to address this. It started as how to address the needs to integrate digital technology in homes, because we're seeing it. You've got Google, you've got Amazon, you've got all these smart home technologies. One thing about a smart home, you can walk into a smart home, and really what it is it's a tablet full of 100 or 200 apps controlling 200 different things. Can we start to think of the home as autonomous? If one manufacturer is building everything in the house, then everything can be integrated. And so we're seeing ourselves as researchers as being that one manufacturer. We're seeing the house, the design as a whole, and all of the technology that comes into it as related to that whole, not as separate pieces. We started years ago, in 2002, we entered as Virginia Tech, we actually helped organize the original Solar Decathlon event, but we also entered it. And since then, we've done 4 Solar Decathlon competitions. This is the 2005 house. It was our second house, and it was just the very beginning of thinking innovation, integrating innovative ideas for transportation and for smart technology. A few years after that was the Lumen House, and this was our peak. Hopefully now is our higher peak, but this was the peak because we took this house to Madrid, Spain, for the first ever Solar Decathlon Europe competition and won first place. We beat all the Germans. We beat the Spanish in energy. And, that was time to, pat ourselves on the back and get home and let's move on. Let's move beyond the Solar Decathlon and let's start to look at not single family homes, but let's start looking at medium density housing. Urban solutions, prefabrication for high-rise towers, these kind of things. But that house was a success, and it was a true smart home. We worked with Siemens, and we developed a lot of, we programmed a lot of software. We had the right hardware, and we made this autonomous house. We called it responsive architecture, where components of the home could kind of move by day and by night according to the weather to allow the house to be as energy efficient as possible. Very successful. It went to Madrid and did well. But because of the transportation concept that we had, which is this transportation component that could attach to the front and back of the house was very portable and could be easily moved around anywhere in just a matter of hours. So after the event, we took advantage of that transportation and we moved it to several locations. We were actually exhibited in Washington, D.C. We were in Chicago on Millennium Park for Green Build. We were in Times Square in New York City for this thing, for the Good Morning America show. It was wild. We were there for just over a day, having dinner in our dinner table, looking out over Times Square. It's wild. The cowboy, right there. And we also had exhibitions. This was at the Taubman Museum, exhibition just of that beautiful stainless steel shade screen that was a product of one industrial designer. So ultimately, what we're doing is we're going to make a comparison with FutureHAUS of can we manufacture houses kind of like we manufacture cars. When an automobile comes off the assembly line, it is a cross section, or it is an example of the technology of the day, right? It's an up-to-date model of today's technology. Meanwhile, you walk into a home, what is it, colonial style? It could be 100 years old. I mean, we're not really thinking innovation with home building, especially when you look at the crude methods of construction. Same with airplanes, right? You sit inside a Tesla and you look at all the technology in front of you, the touch screens, the electronics, the safety mechanisms, the battery, the energy efficiency, right, of the whole thing. Why aren't we thinking of houses in this way? And then turn to the house, and this is how they're built, okay? And if you think of the sequence of construction of a home, the real quick part is the framing. And it's real quick, and it's done by really unskilled labor. I mean, framers come out with hammers and nails, and they throw together this frame in a few days. They dry it in, and then there's this long, drawn-out process of almost up to a year of the trades coming in and installing all their systems within each individual home. It's a horribly inefficient way of building. And what we're doing is taking advantage of the opportunity at Virginia Tech, being researchers, being independent of actually having to deliver, these products that we have to sell, to really explore how do we bring these into a factory. Now, unlike big box modular, which is like double wide trailers and things, which is where really when you build a big box on an assembly line, you're really shipping air, right? You're shipping space. And what I think our big idea is, don't ship the room, ship the wall that defines the room. So if you have two walls that define, say, a kitchen or a living room, those two walls, depending on where you set those modules, you get whatever size space you want, right? So say this is a floor plan, and we saw this as a medium density. So this is really an apartment flat of a high-rise tower. But if you look, these darker gray components we call cartridges. They're smart components. They're plug-and-play components. There's kitchens, there's bathrooms, there's closets, there's laundry rooms. These are all conceptualized as products that are pre-installed, pre-plumbed, pre-wired, pre-finished. There may be complex hardware. In this case, a Murphy bed that's installed in a wall that allows you to change an extra bedroom into a home office. Right, but this is stuff that it's meant to be installed in a controlled environment, because it's a sophisticated hardware. Sit to stand, desks, it's smart, net zero water even. We're looking at water efficiency, not just energy efficiency. And how do we do it? We create a crate that becomes the permanent structure of the cartridge, right? This crate is cut by a CNC, by the robotic equipment that you'd have in a factory. And these components that make up this shell or this frame are absolutely precise. They're 100%, they're up to the thousandths of an inch in precision, right? Because the machine is making these cuts, right? It's not just measured out and there's an error here and there. And that's so important because eventually you'll be installing the cabinets, which nowadays are made by the machines, right? And so now it's a perfect fit. They fit in there perfectly. So really what we're seeing is the components of the home, instead of being like framed walls, they're seen as large-scale cabinets that have all of the integrated technology already in them. A little peek at the past 4 years. So FutureHAUS, we took on one component, one cartridge per year, or maybe 2 per year for the last 4 years, and we developed a smart kitchen. This is a super smart kitchen. It's really looking at the digital technology here, multimodal interaction, so voice control, gesture control, touch to open. Can we think of aging in place as how do we make a kitchen that can accommodate an 80-year-old, 85-year-old person or a 4-year-old person, right? 5-year-old, let the 5-year-old do the dishes, right? But we're looking at the best ways to integrate this technology. And we've had fun with it too, and this is a great project that gets the architects and the industrial designers working with the computer scientists. Computer scientists are used to working alone, right, down in their basement, the programming, right? We're getting them out of their basement. We're getting them working on homes, on actually integrating these things. So having full-scale prototypes is really helpful. This was the bathroom, which was the following year. Now we're partnering with big companies like Kohler. Kohler, they saw what we were doing with this smart technology, and they attached themselves to us and said, well, we want to work with Virginia Tech to see how can we make fixtures, bathroom fixtures and kitchen fixtures smart. They are now one of our major sponsors for this FutureHAUS Dubai project, and we're having a lot of fun. We're now 3D printing a bathroom sink, and it's additive manufacturing, right? It's within the 3D print is also the sensors embedded and the lighting embedded. So it's you'll see it when it debuts in Dubai. It's a pretty wild sink. This is a living room. This was the old FutureHAUS that was about smart lighting. Can the house recognize who's in the house and what that individual is doing and adjust the lighting for that task, whether you're reading a book or if you're watching a movie or if you're cleaning, right? It all calls for a different type of light. The beauty is that bathroom, for example, that I showed you, which was a 2-sided bathroom. It was a master bathroom and a guest bathroom in one. Packages up, I like to say gift wrapped, into this small little crate. That crate is shrink wrapped. Now imagine 4 or 5 years from now, we're going to be going on Amazon and we're going to be ordering our kitchens and our bathrooms. And we're going to know exactly how much that's going to cost. We're going to be able to select what finishes we want in it, what accessories, what types of technology we want in it, what finishes, what style. And we're going to know a delivery date, when that object, just like a television or an appliance, when that's going to be delivered to the site. That's how we're composing, that's how we're proposing in the future houses will be built. It's going to be plug-and-play components that roll up to the site on a flatbed truck. They're going to be unloaded, they're going to be unpackaged, and in 2 or 3 days, maybe a week, the entire house is going to be complete. But it's not like that framed house, which is just dried in. It's actually going to have all of your systems. The systems that ordinarily would take a year to build are going to be installed in just a matter of days. That's what FutureHAUS Dubai is, and that's what I'll eventually show you later in this presentation. We size these components so they nest efficiently on a flatbed truck. So where the old big box modular used to be 16 foot wide load, you'd have to close streets to bring these things in. All of these units fit on a standard flatbed truck. There's no closing of roads. They can park in, along the side of the road to be unloaded. You don't have the problems of staging that you do with things. So we're going to go further. We're actually having a facility built on campus. This facility is going to be our research facility for proposing newer ways to build these cartridges. We're looking at wood construction, steel construction, concrete construction, CLTs maybe, right? What is the best method, what is the best material to move into the future? We're able to prototype these and test these out on the market. Now, that was 4 years of work. We had 12 cartridges constructed, and these were out of this world. I mean, each one had their own really unique qualities and technologies. We had exhibited them at the Kitchen and Bath Industry Show and the National Builder Show for the last several years. Just after the most recent Builder Show in Orlando, we brought the bedroom and home office back, and about a week after we unloaded them into our facility, the building caught fire, and the entire set, all 12 FutureHAUS cartridges, burned to the ground in about an hour. Devastating to us. We believe it was a gas explosion that kicked off from the heating system. And it left us with nothing except our computer drawings and maybe, I guess that was about it. The knowledge, right? We kept the knowledge. For a few days we thought about what we were going to do. But then we decided that we were going to revisit the Solar Decathlon. We were going to do the Peyton Manning, not the Brett Favre. We were going to retire, as number one in the world. Why would you ever enter it again? Well, now our reason to enter it again is not for the Solar Decathlon, but as a way to bring it back, and bring it back quickly and get back to where we left off. But to add to it, energy efficiency, an energy positive home, and a net zero water home. So now it's new and improved. It's FutureHAUS 2.0. It's adding those elements which make the project so much more exciting and better and relevant to building today, right? So here I'll introduce a little bit about the project, the design. The FutureHAUS Dubai team is a group of students, over 50 students from almost every college in the university at Virginia Tech. We're bringing together, it's a great example of the Beyond Boundaries initiative that's happening at Virginia Tech, where they're trying to encourage cross-disciplinary work. We have architects, industrial designers, and interior designers and landscape architects working now with computer science, electrical engineering, mechanical engineering, power electronics, business. It really is. These meetings we have are with students, from all these different areas, learning about each other's professions or majors. It's a pretty good team. Now we're summertime. We're down to about 12. But a great team, a lot of young, a lot of energy, but not a lot of experience. Our experience comes from our partnership with industry. So we're not unlike, I hate to downplay other Solar Decathlon projects or teams, but we really see ourselves as a research program that's working with the industry to take what's happening, the mainstream, what's happening now, and propel it into the future, rather than to say this is a student project where the students are just building a house. No, this is advancing, architecture. This is looking to the future on how to improve the way we do things. So the Solar Decathlon Middle East, it's going to be in Dubai this year. It's going to follow up 2 years later with a big exhibition for the World's Fair. the Expo 2020, which will be in the same location. We're hoping to have our house back for that. But the students have, we've spent 2 years working on this design. We're looking at the materials of the region, the landscape of the region. We're looking at the harsh environment and how does a smart home respond to an extreme condition. And we have gathered a team, these are the 50 students, from every, like the greatest at Virginia Tech. This is CPES, the Center for Power Electronics. This is ICTAS, the Institute for Critical Technology and Applied Science. Additive Manufacturing Lab. This is a Dreams Lab. This is a whole group in mechanical engineering just working on additive manufacturing with 3D printing. Macromolecular Institute, we're working with the chemists and with DuPont on developing new products for DuPont, for vapor barrier. How, if you're going to build in a factory, what type of vapor barrier would you use for these modules? So we're working with the chemists to propose these new materials. Industrial systems engineering. Never really knew about them until we brought them onto our team, and they're helping us coordinate not just the shipping of this thing to Dubai and how we pack it on a truck, but also looking at the factory production and how does this become an assembly line process. It's a very comprehensive project that has turned out, I mean, the best design we've had, and I think this is the best project we've ever done at Virginia Tech with our group. It really is. In about, 4 months, we're going to be here. Pretty scary, right? Talk about extremes. With these cartridges, we're thinking about how is a home designed. If you do order this house on Amazon, you specify where it's going to be. Is this in a tropical climate? Is this in an arid climate? Is it in a place like Dubai where there's desert, heat, and humidity? Very extreme, probably the most extreme kind of environment to build with windstorms added. And then based on what you select, that's what the composition of your walls is going to be. So the whole wall assembly, this is working with DuPont. What type of insulation, whether you have the vapor barrier, all of this is decided ahead of time and then delivered to wherever it's going to go. So we designed for the extreme. There's going to be 22 teams. We are the only U.S. team competing in this. We were the only ones who made the cut when they called for the proposals. And I think it represented, there's houses from countries all around the world, Australia, Netherlands, Asia, just all over. There's no one from China, but a lot of Middle Eastern houses. They're also looking at this competition as being a way for them to explore how they're going to introduce new housing, because they're very much interested in sustainability and in energy positive buildings. Here's our design. This also shows the adaptability of our concept, that context, right? Depends on where you're building. So what we've designed is a house within a house. Okay, it's a house that's very well insulated to begin with, but it's covered and it sits under a canopy. So this is beautiful. I love the concept that it's like a leaf of a tree. That the canopy that's protecting the house, that's putting the house in shade, is that same canopy that's collecting the sun. So it's taking the sun, seeing it initially as a liability, and making it an asset. That we're collecting the energy, and then we're putting that energy into the house. So it's a very, very energy efficient house because it's built with these structural insulated panels, very well insulated and shaded. There's also a wall that surrounds the entire house and makes these beautiful, almost an oasis inside, garden spaces that wrap the house. We're now working with Nathan and his students at the WAC landscape. There's a landscape component, and we're designing the landscape system outside to be an extension of the living spaces inside. We're looking at two main concepts with this. Aging in place, in that when you buy a home when you're young, you live in that house for your entire life, or you share it with many generations, like the Europeans do, right? So in order to do that, and since we're working with modules, we can do this. We have different scenarios or organization of the interior spaces with these moving walls. We call the concept flex space. So during the day, if you need an office, if you're going to work at home, you can draw a wall out and have an office. You borrow space from your living room. If you still want your living room and your office, you can borrow space from the bedroom, close off the bedroom, make a bigger living room, make a bigger office, pull a table out, have a conference room. These are all automatically controlled. You can call out living room and the walls will transform. The furniture moves with the walls. It's going to be a beautiful thing, but think of the impact this can have on the New York City apartment. That you have a 500 square foot apartment or a 300 square foot apartment, very limited space. I have friends who live in that, you know. That during the day you can have your living room, but at night that space becomes the bedroom with very little, effort to change that. The second thing is that's the flex space, and the second thing is aging in place. So with very little investment initially, can you make cabinets that maybe can change levels so they can accommodate a child, they can accommodate someone in a wheelchair, or accommodate even a couple that may be, tall and short, right? We're looking at adjustable toilets. The handicap accessible toilet is very high, but it's a very awkward position to actually use as a toilet, right? So we're looking at the adjustable accessible toilet. And we're doing this fairly efficiently. It's not, a whole lot. It's a $200 actuator and we can make this happen. And then, like I said, we're looking at all of this new technology and we're trying to integrate it seamlessly into how you live in a home. The entire roof is photovoltaics. It's a 15 kilowatt array. It's enough photovoltaics not to just power this house, but to power your neighborhood, right? It's the idea as an energy positive home. It powers the home, it powers your electric car, and it feeds the grid. We're looking at load shifting concepts where we have phase change material in the house on a ceiling that during the day when we're receiving all this energy, we're charging these systems so that we can use them at night when there's no sun. We're charging batteries. We have a Tesla home battery, and we charge that during the day when the sun's out, and we use that energy at night. A sneak peek into what the house will look like. I've drawn these images from old FutureHAUS, very similar but new and improved. Smart islands, touchscreen interfaces, research recipes, flip your recipes up onto the virtual window as a backsplash of the kitchen, right? Skype with grandma and have her show you how to make that apple pie. Or one-to-one, real-time interaction. Integrating appliances and technology seamlessly into surfaces. So a countertop that has an induction area where you can cook, but when you're not cooking, it's just more countertop space. Using the Amazon Dash concept, so the house recognizes your inventory. It knows what's in the refrigerator and what's in the pantry. So when you're grocery shopping, you can be informed through your phone what you need to buy, what you have, what you don't have. We're monitoring we're monitoring your baking, right? You can be mowing the lawn and keeping an eye on what you have in the oven, these kind of things. A lot of what we do is not necessarily we see doing. A lot of what we do is offering ideas to the appliance companies. It's like, hey, this would be a good idea. And they're loving this because they are running with some of these ideas that make a lot of sense. Kohler, for example. How do you use gesture control and voice control seamlessly? We're using a Kohler device. It's an electronic mixing valve, which they use for their showers. We're hacking into that, and we're using it for the kitchen sink. So now you can approach the sink, and you can just say, you know, house, give me 110 degree water. It'll give you 110 degree. You can go up with a cup and say, I need 1 tablespoon of water. It gives you 1 tablespoon of water. So how does it make cooking easier, more convenient? The bathroom, similar things. Sanitation-wise, since we're working in modules, we can have 1 floor, you know, not a lot of tile joints, you know, where mold can build up, or, you know, it makes the space easier to clean. Antimicrobial surfaces. We have a scale integrated into the floor where if you stand in one location, you can get your weight up on the mirror, right? That same scale, which is a sensor, can detect vibrations. So if grandma slips and falls in the bathtub, or she slips and falls on the bathroom floor, someone can be notified, right? A text message can be sent. All of this technology exists in this, or did exist, and will exist again. The technology that made sense and that works. A lot of what we do may not make sense in the end, but other ideas come from that, right? We're working with DuPont on interior finishes. It's my goal in life to eventually, at least have a hand in eliminating drywall from the building industry, right? Nobody likes drywall except the drywall industry, right? It's so easy to damage. People say, oh, but it's so easy to fix. I say, well, it's so easy to damage. And right now, this is your only way, you know, well, at least a lot of building inspectors see it as the only way to get your fire ratings. So we're looking at alternatives. We're looking at materials that offer fire ratings. And we're building with modular wall panels. One nice thing about prefabricating a wall panel is you can take the panel off. Like components on your car, you can take your dashboard off the car and service things behind it. So now a lot of the systems in our house are behind the walls because we have access panels. So you're not cutting out the drywall to fix plumbing. You just snap off a panel and you have it. When you want to repaint your house, take the panels off and have them repainted and put them back on. It makes the process simple, right? So is this a new way? You know, this is a question. We're looking at new ways of lighting. LEDs are so energy efficient, but they're also very versatile. So we're using RGBW. You can tune any color white light or any color, right? We're working on programs that allow for the light to follow the individual through the space. The light follows you. It turns off automatically as you leave. And it also responds to what you're doing. One of the students are having fun with this. So one student is simulating a sunrise. So almost like the circadian rhythm, right? When you wake in the morning, as the sun is coming up outside, it's actually coming up on your ceiling. A deep red orange, right? That comes up and eventually turns into daylight. And you know, immediately when you're waking up, you know what time of day it is. You know, it's like your watch, right? You know, we've demonstrated this in the old house. This was the one that came back from Orlando, but you know, looking at the canopy of a bed as being this experience. That was the Murphy bed. So this with actuators would raise and lower, and now it would allow this wall to move back and forth and adjust the size of the bedroom. We're looking at a different kind of door. No longer do you have the swing door at your front door. Now it's the Jetsons. It's electronic sliding doors. So you can open and close doors with your iPad. You can open and close them automatically. If the house sees that it's going to benefit from operating passively, it's going to open a door on both sides of the house and allow cross ventilation. We have bug screens integrated as one whole layer. So it's 3 layers of doors, one for view, one for privacy, and one for bugs, right? The one door that's for privacy is actually an insulation layer. So your R value in a home, the biggest losses you have in a home are through your glass and through your doors. Well, now we have R16, a thermal value over every door opening. which is huge. It's almost the code for a solid wall, right? That's what an R19 or R21, right? We're approaching that with new technology. We're importing this glass from Japan. It's a new product. It's an insulated glass unit that is pretty amazing. It's a one insulated glass unit. It's R8, because it eliminates the thermal bridging and it has a vacuum introduced. So it's also an opportunity to introduce new products that are on the market that aren't yet ready for prime time, but we can use them in our projects because we're not taking this to market yet, right? The shade screen alone is an exploration from some industrial design and architecture students looking at patterns, looking at traditions of the Middle East. And Majrabia, you know, the privacy screens they have here that are meant for shading, for filtering that harsh sunlight, right? And so throughout the whole house, you'll see these beautiful patterns that are inspired by the Middle East. Again, showing the versatility of a design, you know, if it is factory built. This would be the whole elevation of the front facade of the house, right? It's providing all this shade, but also privacy. So there we are. This is conceptually what it was. About 18 cartridges. This is probably the most important one is right here. It's the spine. And it's the umbilical cord for the house. So the idea is you set all of your components, your plug-and-play components, like Legos. Right? You lay them all out. You bring in the spine, and that spine sits over the hallway that runs down the center of the house. And that's your connection point. All those components plug in along the way to that spine, and that's what allows you within a day to have the entire house powered. We're doing the same thing with the plumbing. We're doing the same thing with the sprinkler system because the competition is requiring that all of these houses are sprinklered. Probably not a bad idea for you, given our history. The last couple of days, here's the scene of Virginia Tech. We're a couple of months out. We've completed it for the most part, the cartridges, but we knew at some point we had to get it out and assemble it as a home first. Because we lost our facility, we lost the space to completely build the house inside and then take it apart. So we had to do it in multiple different spaces across campus. So now was a great opportunity to bring these homes back into one place and see how the thing would come together. Here you can see an entry cartridge. The maximum width we go is 8'6", which is the standard width, the maximum width of a flatbed truck. Most of these components exited our building through a window, through a 3-foot wide vertical window, which we had to cut the frame out and slide it through. But testament to the versatility of this, that these modules are small enough that you can handle them. They're not, you know, so big. This is a door cartridge. So that Jetsons door I was talking about, within that cartridge are 3 rails, electronic motors, and it's going to draw these doors open and close. So, you know, it's going to give you that insulation as well. Working with companies like Masonite. Masonite makes doors. Well, they never thought of their doors actually being used for walls. Well, I like their doors for walls because they're straight, they're stiff. Ordinarily, we'd be taking OSB and studs and framing out a wall, and it still wouldn't give you anything stiff or straight. But a hollow core door is very stiff. So we're introducing some of these companies into products into kind of areas they've never been used for before, and it might open up, you know, a market for these companies. Linac is an actuator company we're using to actuate all of these things. We're giving them kind of ideas on where they can introduce their components in the market. There's that spine constructed. It has all of the HVAC electronically controlled, right? So now dampers that are electronically controlled, that are controlled by the temperature sensor in the room that they're going to be feeding. So if there's no one using the bathroom, why are you air conditioning the bathroom? If you're not in the house, if you're out mowing the lawn, why are you cooling the inside. We can actually use the house as a test bed to compare, is it more efficient to heat and cool the whole house without any kind of variation between the rooms, or individually do this? This is great for the Solar Decathlon because we're able to just cool the rooms where their sensor monitors are located. It's a lot of strategy here too. Uh-oh, I hope the other teams don't see this. The photovoltaics, we look as an opportunity to be a cartridge. There are 5 cartridges. The way photovoltaics are arranged, they're grouped in sets of 10. Each 10 units go to one charge controller, which then goes to the inverter. So all of these are pre-wired. We're almost seeing the photovoltaic system as a modular system that you plug and play modular system. You can go to Home Depot and order a module rather than having a whole team of people come out and do this complex installation. Here was the house. I'm going to show you a little video put together by Virginia Tech, which documents that one day of setup. The thing we have to remember, this is also, and probably most importantly, this is education. So this is teaching young architects and designers and engineers, getting them out in the field, building things. A lot of practical experience here. Working with teams, working with other people. So that's where we are. I just had that plan of that house. You can see can easily be converted to a high-rise building, right? The crane is already there, lifting these prefabricated components. Lots of industry partners. We've got over 30 sponsors. Very active in the project, very excited about the project. So in summary, what are we doing? We're reinventing. We're inventing a new way to build. A new way to build that can address today's technology and today's demands. A new way of building that can address immediate needs for housing. We're looking at solutions that aren't just smart houses. We're looking at solutions that are affordable. We have done work for Fema. We're looking at a disaster relief house. I can show you in a minute if there's time. We're working with HUD on the under $80,000 home, using this cartridge concept, benefiting from this efficient process of building. How to take this technology and seamlessly integrate it into our architecture. The flexible home, like the flex space. How do we make more use out of the space that we do have by using more complex, more sophisticated hardware and a better way of building it? How to make the homes more energy efficient. Now the net zero or energy positive home, this whole aspect is applied to this. A whole half, I didn't talk about this, but a half of the house is powered DC. Those moving walls receive their power from a DC-powered rail above that they slide on. So the TVs, the lighting, everything is powered through DC power. Eventually, when we get away from the competition, the HVAC system is going to run off DC. This is being run directly from our PV panels, which produces DC to begin with. And right now, we have to convert it to AC. Addressing needs or aging in place concepts. We can do this because we have the technology, we have the site fabrication that can easily allow us to do this. Using advanced materials and advanced process. Where does 3D printing come into manufacturing or come into house building, right? 3D visualization. We're working with Spine 3D, an alum from Virginia Tech who's, when you go on Amazon and you select your cartridges, you can actually compile those selections into a 3D model, put on your Oculus headset and walk through that house that you just created. You can actually walk through that house and click on the different surfaces and interchange them with other surfaces. You can have white marble, you can have black marble, you can have, composite. You can look at a wood floor versus a tile floor. You can look at the different types of lighting, different appliances, all of this in real time. So you know exactly what you're going to get, when the house is delivered. Sustainability, right? How to just build smarter and, more responsibly. I have a few things in here. I've talked for a while. It's some of the follow-up projects we've done. I can show you this, or we can take questions now, and then I can show it to you in a minute. Want to do that? Okay.
So is there a floor cartridge, or is the floor something that is built separately and not part of the...
Good question. The doors are actually used as part of the framework, part of those crates that you deliver. There's a continuous hinge at the base, and every cartridge has its own floor component that folds down. So our living room has a floor that folds down, our bedroom has a floor that folds down, and that moving closet cartridge has a floor that folds down from both sides, and you ultimately end up with the full floor.
Those are structural then.
They're structural.
So you still need support footings.
Yes, and that's what those white long things were.
Right.
That was your, okay, so in real construction, you would cast a slab, or you would have your foundation put in. That happens while you're waiting on these cartridges to be delivered. So the actual assembly, there's a month maybe there of the foundation, it's the site work, but then cartridges come, and within a few days you have a home.
A couple of questions.
Yeah.
So one is somehow integrating the five senses into the experience, which you talked about. As you wake up, the screen changes, so on and so forth. There's a tradition, if you were Oasis, to use the gardens for obviously shading, also for food production, and also to, like a healing garden, also engage with the sense of smell. And there's probably water feature which could be easily integrated with solar energy.
Yeah, yeah. The part of the competition is net zero water. We're using a shower system. This is brilliant. This is actually a product on the market. It's not allowed to be used, I don't believe, in the United States yet because of the health department. But what it is a set of sensors in a pre-drain of your shower, and it's monitoring the quality of the water. If the water is contaminated in any way, if it has soap, if it has urine, if it has anything, it's going to divert it to the drain. But as long as that water remains clean, it continues to reuse it. Why be, kind of shocked at this? When you take a bath, you're in the same water taking a bath. And you can take as long a bath as you want, right? Well, now you can take as long a shower as you want. We're recycling. In this competition, with recycling our shower water and with recycling our laundry water, we're using the living machine. We're actually connected to one of the lead engineers of that, who developed that whole concept. We're running our laundry water through a filter, a gravel bed that's outside in the garden. It's a landscape element. And that water will be eventually filtered and reused for laundry only. But out of the 500 gallons of water we use in the whole competition, the 2-week period, we're recycling 475 of the 500 gallons. So we plan to win that competition. We plan to win that. There's a few competitions we plan to win. We plan to win innovation because we really think because we have this 5 years of background on this, we're going to be the only team that's showing up with this kind of idea, with this big of an idea, right? That has a true application. Yeah?
I think you've done well at helping us understand how you've taken some existing or new ingredients or offset construction and assembled them in this new design. A lot of the research shows that offset construction is wonderful offsite, but the issue is when that offset construction comes on
Plug and play. This is the kit house. This is like bringing a cabinet home from IKEA and you assembling it yourself. The instructions are so simple, all right? They're reduced to just graphics. They're that simple, right? It's that spine has your home runs. Each of those home runs are tied into a sub panel for each individual unit, but beyond that, all of the complexity is already done. It's done at the factory. So it's a very simple way of assembling. I thought you were going to ask about renovations, because this is new construction.
Well, that was the next question is,
Okay.
for renovation, and how it was working, like, an urban infill project, where there are certain specific sites, or, if you decide to get up and move, could you just simply go home and reassemble another site?
Yeah, we've thought about all of that. One of the students asked, yesterday we gave a tour through the house, and they said, what if you wanted to switch out your kitchen? And I pointed out where the kitchen cartridge was. The roof spans over it, so the cartridge itself has forklift slots. From the outside of the house, you can come in with a forklift and slide that old kitchen out, renovate it, and bring it back. In the meantime, maybe you have some plywood, over there, while it's waiting, or you already have the new one ready to go. We also looked at renovations. I'll show you this. This is pretty cool. Let's see if this is called kitchen renovation in a weekend. Okay, and that's an IKEA kitchen actually, but the whole cartridge is made. The difference is, in this case, the cartridge is made in two pieces. So the lower half fits in a standard door, a standard 6'8" or 7'0" front door. We started on a Friday, demoed the old kitchen. Of course, what we're missing here is beforehand, we went in and we took a 3D scan of the whole space and located where every electrical outlet was and where the plumbing stub-outs were. Okay, so then we went back to the computer and we designed the cartridge that would fit perfectly on that wall, built it, and then delivered it for that weekend for the install. So this literally is a full-size kitchen renovation that was done over a 4th of July weekend. A lot of what you see is really just a lot of installing of the cabinetry systems. There's no electrical that was done, and the only cuts that were made on the site were just to tie it into the existing walls around, right? Scribing those trim boards.
Joe, this is great.
Yeah, more questions?
But the technology, so as a cybersecurity professional, my concern is all of that technology talking to each other.
Yeah.
How are you addressing?
So there again is the plug and play. One manufacturer makes all of these components. So you have Apple making the cartridges, all working off the same software platform, right? So the one interface, and you may have Samsung with their brand and their line, and you may have, I don't know, maybe Best Buy comes up with their own, home components. So I really see this as being manufactured brands. It makes a lot of sense. They do it with TVs. Why can't we do it with homes, right?
Another question, how should the industry follow suit to catch up as far as financing, contracting, delivery methods? Is this more for design build, bridging, especially as it comes to larger projects?
Joe, if you don't mind repeating the questions that you hear.
Oh, okay.
Thank you.
I'm going to show you. Could you repeat the question for me?
Right, so, obviously the construction industry is inefficient, we know that. So how does the contracting, financing, delivery methods, how do they need to catch up?
That is the challenge.
Is it
Because-
design build, is
right.
it bridging, how do we finance these differently?
So how do we bring this concept to the market? It's a very difficult thing. It's a chicken or the egg kind of thing. You have to have someone to manufacture the cartridges, but then you have to have someone who's going to buy them, right? And until someone comes along and can bring both of those together, that's why I think it's going to be a Google, or an Amazon or some big player that's going to be able to take this on as a whole industry. Every builder that I've talked to sees this. They visit this all the time. They love the idea. They would love to build this way. But I think it's bringing someone big in to introduce this. This is to try this out with a standard house, not a smart home, but a spec home. We built a house in Charlottesville. This is about 1.5 years, 2 years ago. 2 floors, right? There's the floor plan, lower floor and upper floor. The light blue are the cartridges. There were 12 cartridges. There's a typical IKEA kitchen cartridge. There's a downstairs cartridge that contains structure, electrical, insulation, pre-finished. Everything's pre-installed. It's plug and play, right? We brought in a crane, and in one day we stacked this house 8 hours, and had the entire house to this point essentially dried in after 8 hours. Now what's beautiful about this is all the electrical, the kitchen's perfectly pre-installed, the bathrooms are pre-tiled, the plumbing's already in place, the toilet's in place, right? So it cuts down the on-site kind of complexity that happens with all the trades afterwards. We even submitted for a design award and won a state AIA design award. Yeah.
So what did that cost?
That one, we built it for $350, we sold it for $450. And that $350 included the land, $60,000 lot. We took a lot that was hard to build on, because we knew we were going to have a crane. We were able to lift these into their positions.
Did you have a buyer, or you built it on spec?
It was spec. Me and one of my past students, we took out a construction loan. This is interesting. The building inspector, we got them to agree to let us build this way. So they came to our warehouse. We rented a warehouse space, and we built cartridges in the warehouse space. They came, every week and inspected our cartridges, allowing us to do this because we said we were Virginia Tech. This is a new idea, and thank goodness they were, letting. The banks were different. The banks are unforgiving. They would not release our money, our loan money, until those products showed up on the site. So we really funded this thing through our credit cards. We can get our money in. But it was a success. A realtor bought it a month before it was finished for asking price. And now we're kicking ourselves because we should ask for more. One last thing we did, and this really made me excited, is we're working on these cartridges. You look at when these storms rolled through last year. That kitchen renovation that I just showed you, ideal solution for Houston, where all those houses were, and you have to go in and gut the first floors and bring in really fast new kitchens and new bathrooms. This is a great way to do that. But what about disasters like Puerto Rico, where there's no housing, there's no shelter for people to live in? Nobody wants the FEMA trailer because they're awful. So what we came up with is an architectural solution, something that looks like a home, that doesn't look like a trailer. This is the design, but it uses the cartridge concept. I can show you a little video. This is a prototype, and we've developed it since. And the idea is that within the SIPS wall, you have your exterior siding and your interior finishes, all within one wall. You have your windows and doors pre-installed, but the nugget, the kernel inside, is the kitchen and bathroom. All the plumbing's pre-installed, all the electrical's pre-installed. It's really ready to go. We can unload this from a truck and have it set up and livable in 2 hours. We're building them for $35,000 a piece. And we're pitching this to Fema because we think it's a no-brainer as an alternative to that Fema trailer, which cost Fema $65,000 a piece. It's kind of like an origami concept. It's like the floor that folds down. It's the same kind of, you get the volume by unfolding walls. Again, an offshoot of FutureHAUS in thinking of prefabrication and pre-assembly and plug-and-play kind of concepts. So now I've shown you everything.
I have a quick question for you on the
integrated lighting, so it's garden lighting. It's privacy. In the Middle East, every home has, it's walled. It's just the way, they're very private culture, and it's just the way they expect their homes to be. You know, so we had to really look at the culture when we designed this. Like a mudroom entry on that house is a place where you prepare for prayer. So we have a powder room, we have a foot washing station, and we have that moving furniture actually has one scenario that's a modulus, which is a meeting room, right, for this culture. We even have an outdoor modulus the landscape students are working on. But that wall is privacy and shade together, and also design.
What's the target market? Is this just sort of test case, or is there, if this happened, who would buy it and would say to buy?
We don't see it as a product, we see it as a process. We see this, like I was saying, we've got the $80,000 home that we conceptualized for HUD, and we've got the $1 million home that's all these bells and whistles that would be for someone like Toll Brothers, right? Luxury home manufacturers. I think it's the process that we're trying to pitch. It can be, the final product can be anything. John makes me nervous. It looks like he's building up a...
No, I was
Right.
done some projects in Dubai, which they usually somewhat speculative. They're building, they're putting money into it so that they can extract money out later. It's
Yeah.
to be vertical.
Yes.
Only. There are villas, but they're way bigger than that, and there's some internal divisions of usage. It's almost like this is sort of more for the primary customer, this is for service areas, and they tend to be bigger. So I was just trying to, I thought where we were going with this was there's a significant portion of Dubai which has a housing problem, which could be solved by this or going vertically, but that's sort of a different segment where they require compact housing. So I just trying to understand where it's from.
They are interested in flex space. They're not interested in efficient small spaces. They want their villas. And they want, and we have a research project with Jim Jones for Saudi Arabia housing. And it's a big house. It's like a 3,000 square foot house. And we're conceptualizing it in this way. There's no real limit to size.
But it could solve 65% of the service population is huge. They have needs, and so that could be structured.
Yeah, they're importing that. Yeah.
When you say the service population.
Well, Dubai, there's so many empty buildings, and they're all speculative buildings, and the actual Dubai population of people who can own property in Dubai is very, very small.
Yes.
And so the rest of it is just a humming industry
Yes.
that's there to serve this
Yes.
Emirates population. And that's big.
They
have huge housing problems.
they import their labor forces. They're Indians. They are Asian, Southern Asia. They're just buses and buses of workers. They're building all of this stuff, and you're saying we have to accommodate housing for them, right?
For them, but that raises a question where I wasn't going there, but if you've taken, I don't know how this would integrate where you're producing somewhere else, correct, these cartridges, but at the moment they have a culture of having these workers produce, somehow that's going to transform. There will be some loss of their expertise, or it may be transferred to these production centers.
Yeah. Another research project we have in Ecuador, in Guayaquil, where they're relocating. This is a project with Perkins Eastman out of New York. We're brought in as advisors for a concept for their housing. We're putting a factory, an old airport that's being relocated to the outskirts of the city, and they're taking 110 acres in the center of the city where the airport is and putting in a main street. And they want this to be lots and lots of smart homes, smart housing, because they see themselves, Ecuador, they see themselves as wanting to be leaders, smart homes, and innovative. Not just think of themselves as, corrupt or drugs or whatever. They want to be innovative and they want to be manufacturers. So what we're talking about doing is a factory on site that's also a trade school. And the houses that are being built at the trade school are actually being installed in the new city. That's the nice thing about these. It's the machines that build these things are so portable that it's pretty simple to put up a Butler building, get a few CNC machines, under $500,000 for all of your technology that makes these things, and you have a factory. Pays for itself quickly, right, if you have a big development. Thank you. No question from you?
Me?
Yeah.
No questions.
Okay.